Welcome on Cool Paradigms. Here is a new theory concerning the acceleration of the expansion of our universe bubble. An acceleration conventionally explained with the mysterious dark energy, a mystery that disappears with this full universe theory where dark energy becomes the simple gravitational pull from other universe bubbles outside our own Big Bang universe bubble. Note, this acceleration is only observable on a larger scale than galaxy clusters. Postulate. If the universe we observe is indeed the result of a Big Bang, it's only the tiny part of an infinitely larger global universe in which an infinite number of gravitational entities exist and evolve, including a smaller infinite number of other universe bubbles similar to ours. Due to the immense distances separating the different universe bubbles, their overall effects on ours probably only appear as a background noise for electromagnetic waves, and almost certainly as gravitational forces stretching our visible universe bubble. Consequence 1. If an infinite amount of matter is distributed in an even more infinite space, resulting in a relatively low matter density, it's likely that the sum of gravitational influences at a certain point in our universe bubble tends toward a finite limit, which by definition is the observable limit. Consequence 2. The universe bubbles having the greatest effects on our own bubble sides are necessarily the closest. This could explain, on one hand, why effects of external bubbles to ours do not cancel out through gravitational vectors averaging each other's, and on the other hand, why these effects are only observable on a very large scale, larger than galaxy clusters. In other words, the gravity fields produced by these other universe bubbles are so vast and diluted in space that enormous entities are required to observe their effects on our own universe bubble, as well as the even more immense distances that separate a few spherical layers of our universe bubble. For example, for 5 spherical layers, the outermost layer on one conventional pole will be more attracted to nearby external universe bubbles than the opposite pole of our universe, which will be more attracted to the bubbles in its own vicinity. By the way, about huge entities to observe some effects, we can see the same evolution with different senses. The farther the sources we want to observe or measure are, the larger the senses must be. In the case of interest here, the sources are universe bubbles outside of ours, and the senses a powerful enough source of light apart enough to be affected by the so-called dark energy. So supernovas present in distant galaxy clusters are far enough apart and powerful to measure capital information on their speed and path to observe an unexpected acceleration from the supposed Big Bang spatial origin when we expected a deceleration due to the gravity fields of the internal layers of our universe bubble. Conclusion: the enigmatic additional acceleration could be due to gravitational effects of universe bubbles external to our Big Bang bubble. Corollary 1. The additional acceleration of our universe bubble becomes a mean to observe these other universes as they were when they generated these gravitational fields. Considering the distances involved and assuming that our Big Bang bubble has a diameter of 28 billion light-years, the distances to other universe bubbles are likely several orders of magnitude greater, 3 magnitude orders being a probable minimum. This means that the observed gravity fields in action may have been generated for the youngest ones 28 times 10 to the power of 12 years ago, which is the same distance in light years. Corollary 2. Along many sources, the observational boundaries of our universe bubble seem to be larger than what would be allowed by the expansion of our universe and the speed of light. So electromagnetic fields from other universe bubbles could help to explain very distant glowing effects, like the cosmic microwave background. By the way, if you like this video, you can support this channel expansion with a quick free subscription. Thank you for watching.